listening to Radio Data, a podcasting radio where we talk about data, cloud, analytics, and AI with different guests, different hosts, and in different segments. This segment is called Data Journey, where our guests talk about how data moves around in their company, what technologies they use, and what value data brings to their products. Hello everyone, today our guest is Alessandro Romano. Alessandro comes from Italy, but he currently lives in Hamburg in Germany, and he works as a data scientist at Freenow. Freenow builds a highly successful mobile app where you can book a taxi, electric scooter, electric bikes, or other vehicles. I will be speaking with Alessandro about how he and his company use data analytics and data science to build a data-driven product and also innovate in highly competitive market. Alessandro, it's great to have you here. Let's start with the introduction. Could you please tell us more about who you are, what is your background, and what you currently do at Freenow?
Yes, thanks for the introduction and for inviting me here. I can tell you about myself, especially how I started working as a data scientist. I think this is like a question that a lot of people ask me very often, and I understand why. You can probably imagine that there's like a lot of confusion around this role. And when I started, like 6 years ago, more or less, when I started thinking of working as a data scientist, or at least diving into the machine learning field or the machine learning engineering field, there were like a lot of open questions. So back then, regarding my background, I studied computer science, and then I moved to like a master's about data science. Back then, we didn't have this name. The name was a bit different. It was called business informatics. So it was like a kind of mix of statistics, computer science, and some economics concepts, and which makes totally sense if you think about what a data scientist does today. But back then, still there was a lot of confusion. So we didn't have this kind of name in mind of working as a data scientist. And I remember when I started doing my interviews, basically during my last year at the university, I was struggling a lot, looking for like the right company and looking for the data science role. But that was my background. Basically, I was studying to become a data scientist. And I did many interviews. And I remember that I was basically like looking at a lot of profiles, job descriptions, in order to understand what I had to master in order to like enter this field. And then I did like many interviews, and I remember that a lot of people were looking for data scientists, but instead they meant data analysts, as well as data engineering. So they were looking for data scientists, but instead they meant like data engineering. I, after like a while, basically, back then I was also thinking of doing my PhD. But then I decided to accept an offer I got from Hamburg, and I just moved to Germany. So it looked like a new experience, and I started working as a data scientist in the logistics field. So back then, I was working for a startup providing solutions for the logistics sector. And this is basically how I started. And after that, I got a job at Freenow, as you said, which is basically a multi-mobility company now. So it's no longer about taxi. When Freenow started, it was all about taxis, but now they have different businesses in the app. So you get the different services. So you can, as you say, like book a taxi, private taxi, depending on the regions. On the region you're in, you can find the ride-hailing business, as well as like electric scooters and so forth, so on. So the idea is to have everything within one app, which is actually solving a lot of issues. If you live in a big city, you basically don't have to use different apps for different services.
And why did you apply and accepted the offer from FreeNow? What was unique about this company comparing to other companies that you did interviews with?
Yeah, so I knew FreeNow. It's been a while now because it's very famous here in Hamburg, and so I was a user before being an employee, and I was using the app a lot actually. So it was very helpful. Definitely the fastest way to get a taxi. So it was very fascinating. Like it's like one of those companies, when you look at it, you're like, okay, they're probably collecting a lot of data. So as a data guy, I'm looking at FreeNow and like, back then it was called My Taxi. I was looking at it and I was like, okay, they're collecting a lot of data. It will be fun to work for them. So look at this data, see what kind of problems they're trying to solve. And these are like the two things that actually make a company interesting today for data scientists, at least. So you have problems you want to solve, and on the other side, you have a lot of data. So you can imagine that you are having fun solving complex problems, if this is what you want to do, and you have like the fuel for the problems, so that you have the data. Because this is like the biggest like issue today. So if you don't have enough data, it might be very hard to solve like a specific class of problems. And this is what I also started doing at FreeNow when I joined, because of course they told me what kind of problems they were trying to solve. One of them is the dynamic pricing in the ride-hailing business. So every time you get like a taxi, like the private taxi, you know that the price is changing. And it's changing based on the demand and the supply. And this is a very like important and difficult problem to solve. So we spend a lot of time working on this problem. We analyze a lot of signals. And to me, it was very fascinating when I was introduced to this kind of class of problems. And this is the main reason why I decided to join the company. And then, of course, there are like a lot of other reasons why I decided to stay afterwards.
Yeah, it's dynamic pricing is really interesting because in the context of your mobile app, I assume that it must be done in real time, and it should also include a lot of external data, like weather, let's say. So could you tell more about this use case that you implement and how you use data and data science to provide to build the best machine learning model for dynamic pricing?
Yeah. So as you say, it is about using real-time data. If we look at the problem we're trying to solve, everything is based on the signals we get from the market. So we try to propose the best price in order to balance demand and supply. So it's not always about engaging as much drivers as possible or as much passengers as possible, but it's more about balancing the market. So we don't care about increasing the revenue when the difference between the difference between demand and supply is too high. But instead, we want to balance these two signals. And this makes the environment like better. So we can provide a better service. We can increase our service level. And working with this kind of signals, such as demand and supply, it basically involves to work with real-time data and this is also implying the use of specific technologies. So we want to get the stream of data, process them in real time, and apply our solution that can be like a machine learning solution or whatever you want to implement, and then provide in real time a response that is changing the price dynamically in order to make the passengers or the drivers aware that the price is increasing or decreasing. And by doing that, as I say, that the final scope is to balance demand and supply. So this is the tool that we have to improve our service level.
And what are the example data sources or maybe even data streams that you use in your machine learning models to calculate the price dynamically?
If we think of the demand and the supply, the demand is basically how many passengers are requesting a quote, or requesting like a drive. So you can imagine we have in one small city 10 passengers requesting a drive. So of a total of these 10 passengers, they're all requesting like a taxi in that moment. And then we have only one driver available. And these are basically the numbers we're using to calculate the new price we want to show to the drivers and the passengers. And the way we're doing that is that in this situation where we have 10 passengers and one driver, we have a difference between demand and supply. So we see that the demand is very high, but we only have one driver available. Maybe the rest of the drivers, let's assume we have, 5 more drivers, they're all not available, but they already have the passengers in the car, so they cannot be reached. And what we do in this situation, when the supply is very high, we try to increase the price in order to only allow those passengers who are really in need to have the possibility to reach this driver and book the taxi, basically. And we do also the opposite. If you look at the drivers, and then you have a lot of drivers available, but just like one passenger, the price, of course, will be very low, because the only one available, needs to be picked up as soon as possible, because we have a lot of drivers available. And that's pretty much it. So the base concept is very simple, but then the way we're automating and balancing the demand and the supply, of course, involves the utilization of many signals. So now we're talking about the number of drivers, so the number of cars available in one city, and the number of passengers requesting a ride. But you can imagine that you can integrate a lot of different signals, maybe the weather information, as you said, the historical information. So maybe you can look at how the environment responds to during certain peak hours, and you can exploit this information in your model. So you have a lot of new different signals apart from demand and supply you can integrate in your model. The weather, as you say, the weather you mentioned that you mentioned before is something very interesting. So it definitely impacts our predictions. So something we want to take in account, and definitely we work on that because it's a very important component. You can easily think of a situation where it's raining a lot, maybe in London, where we have a very important and huge business, and basically whoever is leaving the job, whoever is leaving the office is requesting a ride. And if it's raining very hard in that moment, everyone will basically open the Free Now app or any competitors looking for a ride and trying to get the taxi as soon as possible, no matter what the price is most of the times. So they don't really care about the price in those kind of situations. So this is definitely something we have to take into account.
Mm-hmm. And how do you check the quality of your machine learning model that calculates the price? Because you mentioned that you would like to balance the supply and demand, but some algorithm can balance it faster than others. And sometimes, because if you put a very aggressive price, you can reduce the demand very quickly. But sometimes you might have some public event that is quite long. Let's say that we have some soccer game or a very big concert, or people commute back from the office, and the demand will not be reduced so fast. So do you have any quality metrics that you use to figure out which version of the model is better? Because I believe that you experiment a lot with those models, you try out some new techniques, new data points, but at the end of the day, you need to choose which model should be working on production.
Yeah, this is a very nice question. And we have a bunch of KPIs we're looking at. So apart from looking at just imagine you're working on like in general, where you have to deal with prediction problem, with a regression problem. The first thing you're looking at is the accuracy of the model. But of course, when you apply the model in production, the business doesn't really care about the accuracy of the model, because if the model is not working properly online, when you apply it to your environment, when you're using the model for like a real life problem, you don't want to look at the accuracy, because if the performances are not good, the accuracy is meaningless. So the accuracy of course is useful when you want to look at the model performance, but then you need some KPIs to track the performance of the model when you're applying it online. And this is what we do. So it's not just about evaluating the model offline, of course, as you said, but it's also about testing it online. And testing the model for us means running a lot of experiments, so dealing with A/B tests. So this is something we do a lot, and we're improving every day in the way we do the A/B testing. And second, the KPIs we're using. So we have a bunch of KPIs we and the business, so our stakeholders, are looking at to understand the performance of our systems. And this is up to the business. So if you ask, like, I don't know, a competitor of us, it might be possible that they're using different KPIs because they want to track something in a different way. Of course, in the end, we're probably looking at the same stuff, but there might be some differences because of the way the business works in that specific city, in that specific country. But this is what we do when we test something online. So it's not just about having a perfect model offline, but then it's about seeing how the model is interacting with the environment when we apply it in production. And this is like one of the big challenge we have. So once we have a model, it's not enough saying that it's performing well offline, because then you're not taking into account the influence that the model is having on the environment once you apply the model itself. And you know that there is a kind of feedback loop between the model and the environment. So you can imagine that in a situation where the demand, this kind of imbalance between demand and supply is very high, the reaction of the model is trying to help the drivers or the passengers to it's like interacting with the price, acting on the price in order to engage more passengers or drivers. But what is happening in the environment is that we get a feedback from them, because then they will react to the new price, and the environment will change very fast in real time. And our model has to adapt to the new changes. And this feedback loop is something you don't have when you test the model offline, unless you have a very good environment where you can simulate whatever is happening in a city. So this is also like another interesting topic. And what you said about special occasions, like football match in a city, like today we have a very important football match, and after the match, a lot of people will start booking taxis with us and the competitors. Well, this is something very tough to take care of, but this is why we have a real-time solution. So we want to have like a kind of general solution that is taking care of these very fast changes you have in a city. And this is basically a very good point. It's basically one of the things we try to improve every day, because the model has to react fast to this kind of events. But in the same time, you don't want the model to surge, to like have this kind of very, like deep slope whenever you're like increasing or decreasing the price. So you want the model to adapt to this kind of situation, because everything, especially in this kind of events, happens very fast.
In your response, you mentioned a few actually very important topics, like multiple KPIs, the feedback loop, experimenting, and your competitors. I would like to add some follow-up questions about them. So maybe let's briefly talk about those KPIs. So in this dynamic pricing machine learning model, what is the most important KPI that you look at, if there is a single one, or if you need to look at many of them actually and interpret?
Yeah, I don't think that there is like a perfect and general answer for the dynamic pricing in general. Like, I think that the answer belongs to the business you're working in. In our case, for instance, it's very important to check how many of the quotes we get from our passengers are converting into actual bookings. But is this enough? Probably not, because you also want to look at the drivers. But now we're already like one step beyond what the data scientist does, because when I look at the model, I'm looking at what I'm trying to optimize. And as I said before, what I'm trying to optimize most of the times is this kind of imbalance between demand and supply. So this is my final goal. I can look at the revenue, but as I say, it is not like the final goal of having a dynamic pricing solution for the ride hailing. And I think the answer is you look at whatever you want to optimize. In our case, I'm looking at this so-called imbalance. But of course, after that, we always look at all the KPIs that our stakeholders, our business think is important for us in order to improve our service. So you want to look at how many of these quotes like converting into bookings. You want to look at how many of those bookings we are sending to the drivers are actually converted into final tour. So if the drivers are if the drivers like the offers we are sending them, and then it's all about how you use this information. You can have many metrics built on top of this funnel, like the creation of a quote, so like requesting a ride, creation of a quote, a booking, the final tour. You can build several KPIs on top of it. And then it's a matter of how you want to look at them. So what is important in this quarter, or maybe for the company in general? And it might even possible that, and I've seen this from stakeholders in general, it's not just about FreeNow. These priorities change very fast. And within 1 year, among different quarters, you might have like kind of plot twist, and then you end up looking at different metrics, different KPIs, because maybe the vision has been changed. And this happens very often. So you have the same KPIs, but you're looking at them in a different way. But definitely it depends on, it's not really about like dynamic pricing, but it really depends on the business you're working in. For us, of course, it's very important to engage as many drivers and passengers as possible. And then apart from how we optimize the model, the second step is to look at the right KPIs that are basically giving us the best overview of how our model is interacting with the environment, and how the environment, in this case, the city, like giving us like this kind of feedback loop.
Yeah, so this means that you collaborate very closely with stakeholders and business owners or people who are responsible for the strategic decisions to define the KPIs that you would like to optimize for, and build a data-driven product that that delivers those KPIs.
Yeah.
And what I also noticed is that the feedback loop that you have in your app is very short and frequent, because you immediately see what is the response from passenger of our drivers. And you can also experiment quite a lot with the price, even the same minute, the same hour. So this makes you different from companies that build, for example, background mobile apps. So, for instance, Spotify is this type of application where you can, of course, skip some songs when you listen actively to that app, but usually you use that app in the background when you work, when you commute, or when you run. And sometimes you might listen to some song that you don't like, but you will not skip it because it's not convenient for you to do that, because the app is in different room, let's say. So, or if you look at retailers, they could also change the price dynamically, but they cannot do that that often. Well, maybe those days where we have very high inflation, they change the price more often, but it's not as frequently as you can do that based on real feedback from the passengers or drivers, because this. We talk about dynamic pricings, but if you look at predictions, like when the driver arrives to the destination, you can predict that this will take 15 minutes, and later you will see what was the accurate number of minutes. And if this is 10 minutes or 20, you can also include that feedback in the model that you develop, so that the model can learn actually the same day from the feedback that you have. So this is quite powerful, that you can get a lot of feedback from the passengers and drivers, and they can give you this feedback explicitly or implicitly.
Yeah, it's very tough for us to get very hard to get explicit feedback from our customers. Mm-hmm. Sometimes we do, but I'm talking about the surge, so the dynamic pricing part. Everything happens very fast. So how can you get like an explicit feedback about that? What you want to do is to just collect the behaviors of these drivers and passengers, understand what you did wrong, what you did right, and then improve the model based on this signal, based on this feedback. And A/B testing plays a very, very important role here. So as you say, we deal with experiments every day, and in order to improve our model, we need to put a lot of effort on designing these experiments, as well as that basically means we need to find the best time to run the experiment. We need to understand what's the target population. We need to understand how to create the control group. We need to understand what's the null hypothesis, how we can have some results we can easily look at. So the designing of an experiment for us means ending up with some results we can easily understand and we can analyze. So we get we collect a lot of data, and we do experiments online, and this is a key part of how, in general, you can improve systems like this.
Yeah, absolutely. And when talking about experimenting, what is the technology stack that you use to experiment, develop new machine learning models, and also deploy them on production at large scale? Because your scale is probably many millions of users.
Yeah. So I can give you like an overview about how, as a data scientist, run experiments and design and implement the models we were working on. But then there is also the machine learning engineering part. I don't have all the details, but I can more or less give you an overview also about that. So first of all, we use Databricks. So Databricks is almost like our main tool when it's about designing and implementing a new model. Also, our data analysis team is using it a lot. So we rely on Databricks in order to have everything in one place. We can use the power of PySpark. So everything is like distributed when we have to deal with big data. We know that we can run like big analysis and we don't have any kind of limitations. And as well as for the data science, for the machine learning part, we use Databricks. So you can imagine, like, instead of just using a normal Jupyter notebook, we're implementing everything in Databricks, or at least like the first MVP, the first prototype is usually made in Databricks. And then, of course, we try to move everything like from Databricks to like IDE. I don't know. In my case, I use PyCharm a lot. So, and even though this is not about the stack, is a very important step, because a lot of people coming from university or like academia in general, they're not used to, then they don't really know that you have to deal with this. So you have to deal with the fact that when you start working in a Jupyter notebook or in a Databricks notebook, then you can have a production environment in Databricks. So eventually your like Databricks notebook can be productionalized, but it's not always optimal. Sometimes you can't do it. And in my opinion, if you're dealing with something with a very big project, you need to work in your IDE. So as I said, I use PyCharm usually. And this is a very important step, because it means like having a more like software engineering view to whatever you're implementing. And then, of course, in our case, we also have to deal with how we can run this code from our local machine in the clusters, because sometimes it's something distributed. So it's something that we have to run on distributed cluster, like the clusters we use in Databricks. So I consider this also part of our stack. And apart from that, we rely a lot on Airflow whenever we have to automate something. So you can imagine that you can build, let's forget about like PyCharm, but you can build your training pipeline in Databricks, and then you can have everything running through Airflow, which is in charge of scheduling whatever you want to automate. And you can also do this in Databricks, honestly. So there is this like option of schedule like a training, but I have tried that, but I'm not always relying on it, because as long as you have everything within Databricks, it works pretty well. But if you want to take everything out, the only way you have to, if you don't want to rely on Databricks and maybe you want to take your code out from there, you still need to use Airflow. So eventually what we do is like whatever we want to execute the Databricks notebook, which contains your training pipeline, you can use this Databricks operator, which is calling the Databricks notebook from Airflow, and then you build your training pipeline from there. So you execute your Databricks notebook, and Airflow will take care of it. And on top of that, as I said, we also use Databricks for a lot of analysis. And then, of course, we have Tableau. Tableau is also like one of our main tools on the data analytics side. I don't personally use Tableau. I have some experience, but this is not something I do. So when I have to deal with visualizations or in general presentations, when I have to present some analysis, I always rely on Python matplotlib. But we do have Tableau, which is basically the way we interact with our stakeholders. But also as a data scientist, I have access to a lot of like dashboards we implement. And regarding the dynamic pricing solution we have in production, we rely a lot on TensorFlow, which is basically helping us to do all of the operations we have to do in real time. And in general, we are like AWS based, but as I will say that this is just like a detail for us. I remember in my previous company, I was dealing a lot with AWS. I was building my own stack. I was working with CDK a lot. So I was basically using Terraform through Python. And I was touching the resources I needed for my stack. I needed for inference, for training, and so forth, so on. In this case, the fact that we're using AWS is a decision that is not really impacting our daily life, like our job, because we don't really see it. As I said, we look at the services we are using every day, like Databricks, Tableau, Airflow. The fact that these services are hosted on AWS is just like a small detail for us. Mm-hmm. For us, in terms of data scientists or engineering analysts.
And for instance, do you also use tools such as MLflow to keep track of your experiments, or Kedro to use some predefined templates of your ML projects?
Yeah, we do use MLflow. This is actually something that comes out of the box if you use Databricks. Integration with Databricks is probably one of the coolest feature you have. And through MLflow, you can easily track your experiments. You have everything in one place. You just have to call one simple function and you track whatever you want. That's very helpful because every time you run you execute a Databricks notebook, you basically you can lose track of whatever the output is if you go through like in a new running. So what you want to do is track all of the information you are getting as output from your notebook and track them through MLflow. So yeah, we use MLflow a lot. It has a lot of pros, and I have to say it's one of the things I really like the most from Databricks.
Actually, MLflow was open sourced by Databricks, so they are creators of this tool. So definitely, this is also nicely integrated in their offering that they provide in the cloud. Regarding the real-time technologies, do you also use technologies like Kafka or Flink for as a real-time streaming data collection and processing?
Yeah, I mean we use them, but we're not maintaining them. As a data scientist, is not like my job to maintain this kind of streams. But yeah, we do have Kafka streams which we are consuming in order to build the final data set we use for the dynamic pricing solution we have in place. So Kafka is our choice.
Mm-hmm. And we have few minutes left, so I would like to ask 2 or 3 final questions. And and one is about your competitors, because the mobility market is very competitive. There are other companies that develop some mobile services, book a taxi or e-scooter. So what is unique about FreeNow, or what data-driven features you provide to make your application unique so the users want to use your app? For instance, you already mentioned that it's very convenient that you can use your app and book many different vehicles, which is convenient in large cities because you can get easy access to them.
Yeah. Well, that's a very tough question. I think that probably there is someone at FreeNow who can answer this better than me, I hope.
Mm-hmm. Yeah. So I'm sure that this is the question that CEO should be asked.
I imagine that he has a very good question for it. I can tell you that my very personal. So first of all, there's my answer as a user. I can tell you that here in Hamburg, having this multi-mobility app is a lot of fun. I mean, you can, as I said, you can just use one app and you do everything with it. I use the app every day. I don't have a car and I don't want to buy one, so having one app from where I can access a lot of car sharing services is very cool. So I do use it every day. I don't think I'm biased. I was using this also before joining FreeNow. But apart from this, I can provide an answer as a data scientist, as someone who is in the data team. We have a great data team. This is my answer. We have a great data team. We have a lot of smart people, way smarter than me probably, and they're great. We work on a lot of cool solutions, and a lot of solutions and also a lot of problems are actually coming from, a lot of questions are actually coming from our team. And we have a huge data team composed by data engineers, data analysts, business people in general, data scientists, and we're doing a great job. I see like people proposing solutions for our problems every day, and they feel like always very involved, ready to help. And as I say, they're all smart. So I think that this is probably, in my opinion, one of the key to for the success, I imagine. As I said, probably someone else in the company, maybe closer to the management, has like a better like answer. But this is what I see. This is what I see from our team. I see that we have like a bunch of people working on a lot of cool stuff. And yeah, I mean, if with the data today you can improve your company. I see that this is what we're trying to do now within my team, and I'm very happy about that.
Mm-hmm. Yeah, I checked also public information about 3Now, and for instance, it's visible that your company and the app is growing very fast, and more employees work there, and more users use the app, which is probably one of the KPI that you also keep track. What is the number of users? What is the churn? How satisfied they are? So so really, really good numbers. Last final question is about the trends that you currently see in big data and data science landscape that are worth watching, in your opinion. So is there something that brings your attention right now that you think will become very important in the near future? For instance, some technologies or maybe some new techniques like graph neural networks, or some other research that is done somewhere that you think that it's useful to keep track of.
Yeah. Well, my view about is not really about new technologies, but it's about old technologies. So it's about technologies we thought we could have started using a lot, and we try to exploit concepts like neural networks a lot. We try to apply to a bunch of different problems and classes of problems, and we didn't really succeed. I mean, I have heard and also seen a lot of stories of people trying to solve problems. I don't want to say like in the wrong way, but they were following probably the trends. So they thought that the AI could have solved everything, and it didn't really happen. So I think that what is happening right now is that we understood that, I'm just saying neural networks, but it can be also something else, that neural networks are not there to solve everything, but they need to be applied to the right class of problems. And then there are a lot of other technologies coming from statistics, computer science, that can be applied in a successful way to a lot of problems that don't need fancy solutions like neural networks. We have talked about that too much, and probably a lot of people follow that trend just to say, okay, this is how we're solving our solution. But in the end, that could have done with a simple regression, or even better with a simple, like, I don't know, implementation of a function you already know about. This is what I usually tell people when they ask me, how did you get there? How did you get to that solution, to that specific solution? I'm always like, well, I started with the function I thought could have solved this problem, and then it didn't work, and I moved to something else, and I moved to machine learning, and then I tried to learn that function. But the step is always like, do you need a function? Just write it yourself. Or if you can't, because it's too complex, train a model and let the model do it for you. And I think that at some point during the last years, But now we were like getting at a point where people really understand how to use this stuff. So during the last years, we lost track of this. We lost track of what's the right process. And we started like filling the market with a lot of technologies based on fancy AI and a lot of buzzwords. And that didn't really work out. And I see that some of them didn't succeed because they were just like selling something that wasn't really needed. And I don't believe that we did that like too fast. So I don't think this came too early. I really believe that people started to applying these solutions to a lot of problems that didn't really require that. So my answer is what I see for the future is like, and this is already happening, is like accepting, like, and understand what working with data, with big data, and working as a data scientist mean now in 2022. So we're basically getting at that point where we know that AI is just like a word, and the technologies, whatever technology we want to use, need to be applied to the right class of problems. And in terms of like technologies, I don't know. I mean, I see a lot of interesting things around. I see a lot of MLOps solutions. I get a lot of emails every day. I believe that some of them can be used by like some of the companies out there. In our case, most of the times when we have to deal with a new problem, this problem requires a custom solution. So it's very hard for us to buy one of these MLOps or AI all-in-one solution, because most of the times we have to build something custom. So I don't see ourselves going in that direction. But maybe some small businesses can definitely like spare some money, and instead of hiring a machine learning engineer, they can try one of these fancy MLOps AI solution at first. It is definitely like a nice way to get into the field, I imagine. But yeah, there is no like perfect and general tool that is always giving you the answer given the data you're feeding into the tool itself. So you need to be aware of that. And so I see that this is like a period where we're learning a lot. We're just forgetting about a lot of buzzwords. We are trying to shape the definition of AI, which can be everything. Like I think that 20, 30, 40 years ago, AI was just like a bunch of rules in a built-in, I don't know, C probably, or even worse, I don't know. So that was AI back then. So I think that AI in the end means nothing, means just that you have something automated and it seems smart. But yeah, we're working on it, and I see that we are like in a on the right track.
When you were answering to that question, it reminded me the memo that the Google CEO sent to their employees about how they should work in the current microeconomics, that they should have sharper focus, for instance. And this suggests me that you need to know what tools, what algorithms, and what technologies you can use for a particular problem, and avoid to over-engineering the solution, or try to build some fancy solution where some state-of-the-art solution could work very well. So,
yeah, and let's be honest, like over-engineered solutions are always very hard to maintain. So I hope I will not be the one who is going to maintain a very difficult and over-engineered solution.
Yeah. So it's also interesting time ahead, to see how the world and also the solutions that are built by different companies can evolve. Okay, thank you, Alessandro, very much for the conversation with you. I hope that we'll see soon.
Yeah, definitely. Thank you for having me here, and we will meet in person in Poland.
Yes. So I will add one information that Alessandro will be speaking at DataMass conference in Gdańsk, Poland, in September 30. So there will be a chance also to speak in person with him for everyone who attends this conference. If you are interested in new episodes of Radio Data, please follow us on Acast, Spotify, and other podcasting platforms. Also visit gettingdata.com to find more information about other ways that we gather and share the knowledge.